For more than a century, the Homestake Mining Company operated the deepest and most productive gold mine in the Western Hemisphere. But it was more than just a mine. It was a physics landmark. In the 1960s, an experiment built by Ray Davis nearly a mile underground detected neutrinos coming from the sun. In 2002, he received a share of the Nobel Prize in Physics. After the mine closed, Barrick Gold Corporation donated the property for use as a dedicated underground research facility. Under the leadership of the state of South Dakota and Mr. T. Denny Sanford, the Sanford Underground Research Facility was born. In total, South Dakota has contributed more than $145 million to bring world-class science to the Black Hills. Today, the facility is operated by the South Dakota Science and Technology Authority under sponsorship of the United States Department of Energy. 4,850 feet underground in state-of-the-art laboratories, world-leading science experiments aim to unlock the fundamental mysteries of the universe. The Majorana demonstrator created one of the cleanest environments on the planet to determine why there are more neutrinos than antineutrinos. The Large Underground Xenon experiment set the bar for sensitivity in the search for dark matter. These elusive particles make up nearly 80% of all the matter in the universe, but have yet to be directly detected. And South Dakota universities are playing a leadership role in science at the facility. Black Hills State University operates a deep underground cleanroom facility studying the radioactivity of materials used to construct underground experiments around the world. The only low-energy underground linear accelerator experiment in the United States is led by the South Dakota School of Mines and Technology. CASPAR created conditions that could reveal how elements heavier than iron are formed in the stars. 2 future experiments have been given the highest priority in the high-energy physics community. Lux Zeppelin, the next-generation dark matter detector, will be the largest and most sensitive dark matter detector yet, and has the best chance for finding the missing mass of the universe. And then there's the Long Baseline Neutrino Facility and Deep Underground Neutrino Experiment, the largest international mega science project located in the United States. Success could mean another Nobel Prize in Sanford Lab's future.
This is Fermilab, a Department of Energy national laboratory near Chicago. It's the starting place for the Deep Underground Neutrino Experiment, DUNE, powered by the Long Baseline Neutrino Facility, LBNF. The experiment begins with Fermilab's accelerator complex, which moves protons close to the speed of light. It's all part of an effort by more than 1,000 scientists from around the world to figure out how tiny particles called neutrinos work, and what role they play in the evolution of our universe. Neutrinos are the most abundant matter particles in the cosmos, but very hard to catch. Trillions stream through you every second without leaving a trace. At LBNF, the beam of protons will smash into a target, creating the most intense beam of neutrinos in the world. Scientists will collect data to measure properties of neutrinos close to the source and again far away. Neutrinos change as they travel, so scientists are sending them straight through 1,300 kilometers of rock toward the DUNE detectors at the Sanford Underground Research Facility in South Dakota. The detectors can also look for the birth of neutron stars and black holes by catching neutrinos from exploding stars. The 1.5 kilometer deep detectors will be filled with 70,000 tons of liquid argon, making them the largest neutrino detectors in the world. As neutrinos interact with the cold liquid, they create a shower of other particles and light. Those particle tracks are then picked up by electronics and transmitted as data to the surface. The information will be analyzed by scientists at collaborating institutions in countries around the world. They'll use this data to solve unanswered questions about neutrinos, and maybe even figure out why matter exists, things like planets, stars, and even you.